Hi everyone, it's Math with AUB. I have written a question how to form a differential equation. How to form a differential equation, let me say ordinary differential equation, not partial differential equation. In ordinary differential equation, we have single independent variable. I have written a equation of circle x minus h whole square plus y minus k whole square is equal to r square, where center is at hk and radius are. H and K are mentioned here, they are arbitrary constant. How to form a differential equation? There are two arbitrary constants, H and K. We are allowed to differentiate at most two times. Because we have two arbitrary constants. Using this equation and two derivatives, total three equations, we have to get rid of this h and k. Whatever the result without h and k, it is our required differential equation. Let me repeat again. The number of arbitrary constant here are 2, h and k. The given equation 2 plus 1 3. Using these three equations, two derivatives with respect to independent variable and the given equation, we have to eliminate h and k. There are two arbitrary constants. We allowed to differentiate two times. Let's jot down to work. Let's eliminate the arbitrary constant h and k to form differential equation of the circle having center at hk, radius is equal to r. Let me write equation again. X minus h whole square plus y minus k whole square is equal to r square. That's our equation number 1. We have two arbitrary constants h and k. We have a free hand to differentiate two times, at most differentiate two times. Differentiating with respect x, let me write differentiate with respect x, we have two times x minus h, make the power coefficient subtract 1 from the power, differentiation of x is 1 and h is a constant having derivative 0, plus applying power rule 2 times y minus k, subtract 1 from the power, differentiation of base, derivative of y is dy over dx, k is 0, r square is also constant 0. It can also be written as 2 times x minus h multiplied by 1 having no effect, 2 times y minus k times dy over dx. That's our equation number 2. Again differentiating with respect to x, we have, prior to this, if I multiply 2 throughout, okay, let me differentiate that. 2 times differentiation of x is 1 and h is 0. 2 times, apply here product rule, because there are two functions in multiplication. Product rule, apply product rule, that is first same y minus k, differentiation of dy over dx is double derivative d square y over dx square, plus dy over dx same, second function same, differentiation of 1 y minus k is y minus k only is dy upon dx, k is 0, is equal to 0. Okay, it will become 2 plus 2 times y minus k double derivative d square y dx square plus 2 times dy over dx whole square is equal to 0. Taking 2 common or dividing throughout by 2, we have 1 plus y minus k times double derivative plus dy over dx whole square is equal to 0. Solving for y minus k, here I have something, y minus k times, solving for y minus k, d square y over dx square is equal to shift 1, as well as this quantity here, it will become minus 1 minus dy over dx whole squared. Solving for y minus k, we have y minus k, taking minus common, 1 plus dy over dx, that's whole square divided by the double derivative, d square y dx square. That's our value of y minus k. y minus k. Also managing the value of x minus h from here, taking 2 common, dividing by 2, x minus h is equal to, in that case shift that quantity here, I have negative y minus k times dy over dx. Now plug in the values of x minus h and y minus k in the original equation, then we have our required differential equation. Let me write again, x minus h whole square y minus k whole square is equal to r square. First let me replace the value of x minus h here. What is the value of x minus h here? That is negative y minus k dy over dx whole squared plus y minus k whole squared is equal to r squared. This negative will be neutralized, it will become positive. So I have y minus k whole square dy over dx whole squared plus y minus k whole squared is equal to r squared. Taking y minus k whole squared common, we have single derivative squared plus 1 is equal to r squared. We have the value of y minus k, plug in here and square. So we have something minus 1 plus single derivative squared divided by double derivative dy upon dx whole squared. Y minus k has squared, it will become overall squared times, this is same, dy over dx squared plus 1 is equal to r squared. This minus will be neutralized, this minus will be neutralized, this minus will be neutralized. I have something like 1 plus dy over dx squared whole squared divided by d square y upon dx square whole squared is equal to, times dy over dx squared plus 1 is equal to r squared. Shifting this quantity here, we have something like, I have 1 plus dy over dx squared whole squared times dy over dx squared plus 1. Shifting this quantity here, it will become r square times double derivative squared. These both brackets are identical, they are multiplication, like x square into x cube, 1 plus dy over dx whole square squared times dy upon dx squared plus 1, we can multiply them, it will become 1 plus dy over dx squared whole cube times r squared times double derivative square. It is our required differential equation of this circle, x minus h whole square plus y minus k whole square is equal to r square. Some writers take square root and they write in that fashion. We have 1 plus dy over dx whole squared, taking square root both sides is equal to, 1 over 2 means 3 over 2, it will become r times double derivative, either leave here, This is the required equation of circle where hk is the center, r is the radius. We have just got rid of the arbitrary constants h and k. There are two constants, differentiating at most 2 times and utilizing the original one equation 2 plus 1. If you have n arbitrary constants, then you have n plus 1 equations to get rid of n arbitrary constant. There are 2 arbitrary constants, 2 plus 1 3. So I have utilized 2 derivatives and the single original given equation. Utilizing 3 equations, I have got rid of h and k. This is the way how to form a differential equation. In appearance, it might look simple, but it is time consuming as well as demanding concept and clarity. See you in the next question.